discuss a question related to circular motion. So this is actually a past paper question, and there are a lot of things to learn from this question. That's why I selected to discuss this one. Right. Okay. So the question is: a small object is placed inside the right circular cone with axis vertical and vertex down, as shown in the figure. The coefficient of static friction between the inner surface of the cone and the object is mu. What is the maximum angular velocity of rotation? That's important, right? You may underline that one also. What is the maximum angular velocity of rotation of the cone about its axis for the object to be on the inner surface of the cone without slipping at a distance d away from the axis, right? So you have the question and the diagram on the screen. So I will draw the important part only. Okay. So this is my inclined surface of the cone. So I can mark the angle here, that is theta. And this is the axis of rotation of the cone. And I can mark the forces on here. So this is the object, and let's mark the forces. So obviously there should be the weight of this one. So it is acting downwards. This is weight mg, and there's the perpendicular reaction force from the surface on the object. We will label it as capital N, the normal reaction force. And again you can label the angle also. If I draw the vertical axis here, so you can mark the angles. So what are the angles, right? So I will extend this one also to here. So you know that if this angle is theta, then this angle must be theta. These are alternating angles. If this angle is theta, this angle also become theta. Then this is 90, right? So this one become 90 minus theta, therefore this one is 90 minus theta. So if I draw the horizontal line like this, so I can take this angle as theta, right? Hope it is very clear to you, right? If it is not clear, please let me know, right? So here this is theta, so I have a vertical line here, and this is my inclined plane. If this is theta, this is also theta, because that is alternating angles, right? And this is also theta, opposite angles. So in this small right angular triangle, this is theta, this is 90, therefore this one should be 90 minus theta. Then this one is 90 minus theta. If you draw the horizontal line, this angle is 90, then this angle must be theta. So it is very important that you draw the diagram properly and mark the angles. If you miss any angle, then it will be a problem during the calculation. Your sine cos will be interchanged if you mark in a wrong manner, right? Okay. Then it is given that the distance is d. Is the separation d. So the radius of the circle will be simple d. And the friction is there. So this is very important thing. Okay, marking friction is the most important thing in this question. So it is given that what is the maximum angular velocity. So when this is rotated with the maximum angular velocity, the possibility is if you rotate more than the maximum velocity, what will happen is this object will slip up, because the centrifugal force is too much powerful and it is being pushed away from the center, right? So definitely if you are rotating with the angular velocity greater than the maximum velocity, maximum possible velocity, this one will slip up. So the friction will be in this direction, in the downward direction, capital F. So for the knot, if you are having the minimum velocity, what will happen? if you are rotating with the minimum velocity, so if you rotate with a velocity lesser than the minimum velocity, what will happen? So the centrifugal force is not enough to balance its weight. So then this one will start to slip downwards. Then in this case the friction will be acting in the upward direction. So this is the only difference in these two scenarios. For the maximum velocity, friction will be acting downwards. For the minimum velocity case, friction will be acting upwards. So this is the only difference, right? So you know, now you have marked the angles, right? You know this one is also now theta, same, no? This is theta. Now you have angles and now you have marked all the forces. So it is almost done actually. So what are the two steps of solving a horizontal circular motion? So this is a horizontal circular motion because this cone is rotating like this. While when it is rotating, we can assume that this one is stationary here. So if not, we can take the other way around, like that way. Cone is stationary and the object is moving. So if you consider like that way, you can easily think that it is moving in a horizontal circle. So this is a horizontal circular motion. So when you solve the horizontal circular motion, there are two steps for the question to solve. The first step is to apply F equals ma towards center. So the center of this motion is here, right? This is the center of the motion. So you can apply F equals ma towards the center, and the second step you can apply vertical equilibrium, because when this is moving in a horizontal circular motion, it will not jump up and down. No movement in vertical direction. Therefore, you don't need to have equations or motion equations in vertical direction. So it should be vertical equilibrium. Then only you can have a perfect horizontal circle. Right. So now we will apply F equals ma towards center first. So F equals ma towards center. So remember, when you apply F equals ma towards center, this acceleration means this centripetal acceleration. It can be written as two ways, r omega square or v square over r. So these are the two ways to write the centripetal acceleration. Right. Now what are the forces acting towards center? So we have n component from n, that is n cos theta plus we can get from here component f sin theta normal forces, that is equal to m. So the question is asking angular velocity. So you may put the omega equation. So the radius is d, md omega square. Now you can simplify a step more. So you know that friction you can easily written as friction is equal to, so coefficient of friction is mu, therefore friction you can write as mu times capital M. So by applying F equals ma towards center, you can get the equation n cos theta plus f sin theta equals md omega square, and you know that friction is equal to mu times n. Now you can plug in here n cos theta plus mu n sin theta is equal to md omega square. Right? Now here you can see n is common, so you can take n outside, or you can keep it like that and divide. Okay? So we will keep it like this because it's more another step, additional step. So this is my first equation. Then what I can do is, now I can apply the second step, that is when in horizontal circular motion, it should be vertical equilibrium. So I can apply vertical equilibrium here in the vertical direction. So what are the forces? N sin theta is there, and you have F cos theta. So this is upwards, other forces are acting downwards. So if you consider the equilibrium, upward forces and downward forces must be equal. So n sin theta is upward and F cos theta is downwards. F cos theta plus there's a weight mg. Now you can see some relationship cos theta sin theta in the left hand side. So you better take this one to this side. Then n sin theta minus F cos theta equals mg. Now you can again plug in F equals mu n here. So you can plug here n sin theta minus mu n cos theta is equal to mg. This is my equation number 2. Now to find to find omega, what I can do is I can divide these two equations. So I will divide the first equation by the second equation. I will write down the second equation here, right? It will be n sin theta minus mu n cos theta mg, right? Now we can do simplification easily. Here n is common for all 4 terms. You can cancel out here and you have m here. Now you can take g here, you can take d here. So I will take them. So this d now will be located here. I will put a bracket here. Now this d in the upper side will be located here now, and this g can be taken to the other side as g here. So it is omega squared is equal to this one. Now you can directly write omega is equal to g divided by d bracket cos theta plus mu sin theta divided by sin theta minus mu cos theta, and that is omega squared. So you better take the square root to get the correct answer. So this is the correct answer, right? So you can try the other way around. So you can try the question for the minimum velocity also, because in the upcoming years, so they can give this one also, because they have checked whether you understand the concept. So with the maximum velocity, it is moving upwards, there are friction downwards. With the minimum velocity, the object will tend to move downwards, therefore the friction will be in the upward direction. So understand the question properly, and I don't think that this is a very simple question. So, but this is the 50th question, you know. So that means most of the students will think that this is a very difficult question, but this is a very, very easy question. So if you know the concept well, if you know the steps well, if you can do the simplifications quickly, then everything is very simple, right? Thank you very much for joining with me to discuss a very important question in physics. So we will meet again in another interesting video with a new question, right? Okay, thank you very much. Also, just to remember, please let me know any questions that to be discussed like this, because I am really willing to help you, because I know that the examination is coming very much closer. Every day you may have some exams. So actually I am willing to help you, but your comments and your feedbacks is very important to develop myself and my channel. So please let me know your comments on this one, and please send you a difficult question so I can make them easy for you. So thank you very much for joining again. So see you in another video.